Have you ever put a full kettle of water on the stove, walked away, and completely forgotten about it? Water boils over because the system lacks any physical mechanism to monitor its own state once you leave the room. Any system that generates massive power becomes a liability the exact second human supervision is removed. Modern artificial intelligence faces this exact same unattended pot vulnerability. We can prompt a model to generate thousands of lines of code in seconds, but without a human to verify the logic, the model eventually veers off track and begins to hallucinate. Software engineers are solving this problem with a mechanism called the agent loop. This loop gives the AI a built-in monitor that remains focused on the task long after the user has looked away. Early industrial steam engines faced a similar bottleneck. They produced incredible mechanical power, but they were completely blind to how fast or hot they were running. Factory owners had to station workers directly next to these machines, tasking them with standing watch for hours to prevent stalling or catastrophic boiler explosions. Because the engine couldn't sense internal pressure, humans had to constantly stare at a physical gauge and manually twist valves to keep the system stable. The ceiling of early industrial production was strictly dictated by the limits of human attention. The mechanical solution to this exact supervision problem was the Watt governor. Two flyballs on a central spindle connect to a steam valve. As it spins fast, centrifugal force pulls them outward, lifting the linkage to restrict steam. When the machine slows, the balls drop, pushing the linkage down to let steam back in. The system achieves an automated equilibrium. For the first time, a machine was given the physical ability to monitor its own output and correct its course without human eyes. A standard AI text generator is just as blind as those early steam engines. It produces output, but it doesn't know if that output actually works. The agent loop applies the Watt governor to code. Instead of stopping, it routes the script into a testing environment. If it fails, the system detects the error and loops feedback back to the start. It cycles continuously, stopping only when the code runs perfectly. Within this architecture, every failed test serves as a crucial feedback signal, forcing the software to reevaluate and fix its own mistakes. We can see the difference clearly when we look at how most of us interact with AI tools today. Right now, you probably type a prompt into a chat window, copy the code it generates, run it on your own computer, and then manually paste any error messages back into the chat. In that workflow, the human user is the one doing all the evaluation and correction. You are acting as the manual Watt governor. An agent loop workspace handles that entire back-and-forth process in the background. It generates the script, runs it, reads the errors, and fixes the bugs, all on its own server. True autonomous workflows remove the human from the center of the feedback loop, presenting you only with the verified, functioning final product. Managing a powerful system requires the machine to recognize when it has veered off course. Real automation relies on this ability to sense a deviation and automatically pull the system back into alignment. Look at the daily tools you rely on. Do they force you to be the constant error checker, or do they have built-in loops? While raw generation provides the power, it is the ability to self-correct that defines truly advanced intelligence.